Hi, today we're gonna see elastic energy and its applications. Okay, what's energy? On physics, there are different types of energy, like kinetic, potential, mechanical, thermal, gravitational, sound, elastic, like, and electromagnetic. But the two main and the most used types of energy are the potential, that is the non-moving energy, and the kinetic, that is a moving energy. But today we're gonna focus on elastic energy. What is elastic energy? Elastic energy is elastic potential energy is the energy stored as a result of applying a force to deform an elastic object. The energy is stored until the force is removed and the object springs back to its original shape, like we can see on the image. It springs back, the rubber band springs back and goes back to its original shape, doing some work in the process. The deformation could involve compressing, stretching, or twisting the object. There are some applications, some specific and design applications that use elastic energy. The first one is on a vent diving board. When a diver is, is jumping on a diving board, it's exerting some elastic potential energy, and we can see the process here. Energy is converted into different forms during the diving motion. When the diver is on the board, he or she exerts a force to bend the diving board. Some energy is stored as elastic energy on all the board. Then the diver jumps, and some chemical energy in the diver's body and some elastic potential energy of the board is converted into the diver's kinetic energy. And that's the end of potential energy, because when the diver reaches the highest point, he just expels some kinetic energy and is converted into gravitational potential energy. As we can see on this GIF, the board is making some move, and that little move is the elastic potential energy that the diver is exerting on the board. Okay, another example is the rubber band. When you stretch the rubber band, the rubber band is making some elastic energy. It's so easy because you just stretch it, the energy is stored, and then you take you unstretch it, and that's it. That's all the work of elastic energy there. Another example is on a bouncing ball. There are some energies used when a ball bounces, but elastic energy is just shown when the ball is on the floor. Let's see. When the ball is not moving, there is no gravitational potential energy. Oh no, yeah. The gravitational potential energy is at a maximum, sorry, but it has no kinetic energy and no elastic potential energy that we are seeing. When the ball falls, the gravitational potential energy is changed into kinetic energy and the ball accelerates. And then when the ball already hits the floor, the kinetic energy is changed into elastic potential energy. And then the ball regains to its shape, because when the ball hits the ground, it's change. It deforms the ball, and then the energy is transferring to kinetic energy again when it goes on the air. But it's a good example here that we see elastic energy, because the ball has a really showing a really big deformation when it's on the floor, and that's elastic energy. To conclude, elastic energy is the result of the applying force to deform an elastic object. As we saw on our examples, the board has some change on itself. the bouncing ball deforms too, and the rubber band is stretched and deforms to its normal shape. I found a phrase of Hooke Law that was the person who proposed this energy, and he says that one of the properties of elasticity is that it takes about twice as much force to stretch a spring twice as far. This means that in the rubber band, the elastic energy is going to take more force to stretch to get it than the spring that we have here. It's just something that you can apply to the formula to make the formula easier. One of the questions that I have that I didn't wrote was how elastic energy is applied on an arc. I didn't find information because I saw in some pages that elastic energy is applied on the arm and not on the arc, and that's what gives me some doubts and some questions because I thought the arc was the one that makes the elastic energy. My references, and that's it. Thank you.